Welcome to Point to Point channel. Today I will discuss about at the rate many to one unidirectional association in Spring Data JPA. So I'm going to cover these concepts like what is at the rate many to one annotation. So when do we need this, and how to insert child entity records, and similarly how to fetch child entity records, how to delete a specific child entity record, and how to delete all child entity records for a specific customer ID. Okay, so without wasting time, let's jump into the coding part. Yeah, so just some time before I have created a demo project for this particular scenario. So here if you see, I have two entities. So one is customer and the second one is loan. Here you can see loan. So here customer is a parent entity and loan is a child entity. So that means one customer can have many loans, and many loans are associated to one particular customer. So that's why we have at the rate many to one. Here you can see loan is having ID, loan amount, and loan issue date. Okay, and here you can see um, this one at the rate many to one. So I just annotated with the at the rate many to one. Okay, and cascade is equal to cascade type dot persist, and fetch is equal to fetch type dot lazy. Here you can see this is a parent entity instance. So private customer. Okay, so that means we are having a association from child entity to parent entity. So that means since we have added private customer within the loan entity. Okay, so by that way we have established a unidirectional association from child entity to parent entity. Okay, so that's why you can see my project name also child to parent. So whenever you insert a loan record, automatically associated customer record also gets inserted. Okay, so why? Because we have enabled cascade is equal to cascade type dot persist. Similarly, whenever you fetch loan record, okay, so what you say, it will fetch the loan record, and whenever you try to fetch its associated customer details with the help of like loan dot get customer dot get name, so then it will fire one more query to fetch uh, associated customer details. Why? Because here we mentioned fetch is equal to fetch type dot lazy, right? So now here if you see this parent entity, here we have hardly three fields: ID, name, and this mobile number. Okay, so here if you see we don't have any information of child entity over here. So that means we do not have any association from parent to child entity side. Just note this point. Okay, so here now coming to repositories, we have one and only repository, that is the loan repository. We don't have one customer repository. Why? Because we are not going to do any operations with customer repository. Sorry. Okay, so I have added one derived method. So this is a JPA derived method, delete by customer ID. So what does it mean? So it will delete all the loan records which are associated to a specific customer. So we are just passing that customer ID. It will simply delete all the loan records of that particular customer. So in order to make it success, we need to add at the rate transactional for this particular operation. So that we will discuss after some time. Okay. So I have one utility class. I mean, I just wrote this class just to showcase the usage of lazy loading that we will discuss later. Okay, so this is just a main class in which we have a main method which is annotated with the red Spring Boot application, all the general stuff. Okay, and this is a resources in which we have application.properties. Here I just maintained all the data source properties of MySQL database. Okay, yeah. And here if you see, I have some test cases. Okay, so I have written few scenarios for CRUD operations that we will discuss now. Okay, so this is a high level code walkthrough of my demo project. Okay, so now so now let's see one by one operation. Okay, so here if you see, yeah, here if you see, I have one customer. Okay, customer, what do you say, record. Here customer is good, new customer. Okay, so here if you see, this particular customer one has three loans. Here you can see three loans. So that guy has a personal loan, home loan and car loan. Okay, so whenever we create a loan record, okay, obviously we need to pass respective customer, right? Here you can see, so this customer here we need to pass. Why we need to pass here, in the sense, if you open the loan, okay, so I guess, I mean, you guys have a idea of Lombok. Okay, so here you see, at the rate getter setter, at the rate entity, at the rate noaux constructor, at the rate required aux constructor I have. So required aux constructor, in the sense, I mean, of course, yeah, so required aux constructor, in the sense, I mean, whenever we create a constructor with a new operator, so I want to pass only these three field values. So that's the purpose of required aux constructor. So for that, we need to annotate with at the rate non-null. Okay. So that's why we are supposed to pass this customer reference also whenever we create a loan record. So as part of that, I mean, I just pass this customer one. Okay, and simply loan repository dot save all of I'm just uh, turning out to, what do you say, these individual loan records in the form of list. Okay, I'm just invoking save all operation. Similarly, I'm just performing one more set for the customer 2. This customer 2 has only two records. Okay, personal loan and home loan. I'm doing the same operation. Okay, so before okay, before invoking this particular one, let me show you in the database. Here you can see this is MySQL database. I'm just refreshing. Here you see, I don't have any tables. Okay, I just created a schema. Of course, we need to create this test schema. Okay, as soon as I execute my test case, immediately it will create two tables. That is a customer table and loan table. I will show you shortly. Okay, so I'm just running. Okay, meanwhile, I will tell you one more point. Here you see, we are saving a records with the help of loan repository only. So we are not doing any operations with customer repository. Moreover, we don't have customer repository itself. Why? Because we are discussing at the rate many to one unidirectional association from child entity to parent entity side. Okay, so yeah, it will take a while. I'm just minimizing this. So internally, what does what it will do? So it will create a foreign key column in the child entity set, that is a child table, nothing but a loan table. So within that, it will create a foreign key column with some default name, some customer underscore ID, something like that. Yeah. So here, if you see, loan, yeah. So if at all we want to customize that newly created foreign key column, we need to give one more or something like this at the rate join column or something like that. Okay, that I don't want to give this one. Okay, now let's examine the database. So I'm just refreshing. Yeah, you can see customer and loan tables are created. Now I'm just refreshing. Okay, so this is a two records are created for customer. Here you can see, I'm just refreshing. Yeah, here you can see five records are created. So first three records are associated to the customer one, and the fourth and fifth record are associated to customer 2. So very clear. Okay, so now now let's do few more operations. Okay, so here if you see, yeah, this operation. So here if I want to fetch a loan record. Okay, so for that, Okay, for that, if you remember, I have annotated with the at the rate, sorry, not at the rate, fetch is equal to fetch type dot lazy. Okay, so that means whenever I fetch a loan record, it will fetch only loan record. It will never fetch its associated customer record, right? So that obviously then whenever I try to invoke uh, what you say loan dot get customer dot get name, it will throw lazy initialization exception. So that I have covered in my previous videos. Okay. So just to overcome that issue, uh, I just wrote one more class with what do you say? Here you can see lazy testing. One more class. Okay. Here I just annotated with at the rate transactional. Okay. So here, here if you see, I'm just fetching a loan record. Okay, find by ID of so and so. Okay, whose ID is one. Okay, then I'm just examining. I mean, loan dot get amount. Okay, so and so amount, and loan dot get customer dot get name. Okay, so if you see, whenever the flow reaches here and tries to execute this particular line, then only it will fire one more record. Okay, that we will see now. Okay, so I'm just debugging this one. So meanwhile, let's keep the breakpoint over here. Okay. Meanwhile, I will cross verify. So first record loan amount is 2.5 lakhs, I guess. Okay, let's see. 2.5 lakhs. So if I scroll up, yeah, 2.5 lakhs, correct. Customer name is Rajendra, correct. Right. So let it stop. So yeah, it will take a while. What happened? Yeah. Yeah. So here you see, yeah. So already flow reached to the line number 20. So that means it has already fetched a loan record whose ID is one. Here you can see. So select loan something blah 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 from loan where loan ID is equal to something. That's it. Okay. So since it is a lazy fetching, it has I mean it has not fetched its respective customer details. Okay. Now let's go to the next line. Okay. So here if you see now I am trying to fetch its associated customer name. Okay, now it will fire one more request here if you see. Yeah, so here you can see it has fired one more request. Okay, to get the customer name. So that's the beauty of lazy loading. I'm just resuming the flow. Yeah, test case passed. Okay, so now let's see one more test case. Okay, yeah, so one more test case. So here if you see what I'm doing, delete loans by loan ID. Okay, here if you see delete by ID. Okay, this is a what do you say predefined method. Okay, in Spring Data JPA. So whenever you want to delete a record, just delete by ID. You need to pass that particular ID. Okay, so here I want to delete a loan record whose ID is one. Okay, so once I delete, I just want to cross verify again. I am fetching that particular record. So if it really gets deleted, obviously, I mean, uh, it will return false. Loan dot is present returns false. Okay. So now, before executing this particular test case, I want to say one more point here. Okay. So what I want to say here is, okay, yeah. See, now I'm trying to delete a loan record, right? So here, do observe that. Okay. Here I have specified cascade is equal to cascade type dot persist only. So do not give cascade is equal to cascade type dot all. Okay, or do not give cascade is equal to cascade type dot remove. Why? Because if you give cascade is equal to cascade type dot all or remove, then what happens whenever you try to delete a loan record? So because of this cascade is equal to cascade type dot remove, it will internally tries to delete associated parent record. Associated parent record in the sense this customer record, right? So now, as everyone knows, okay, whenever we want to delete a parent record, obviously, uh, first of all, we need to delete its respective child entity records. Then only we are eligible to delete a parent record. It's a general, what is it, general database rule, right? So here, if you see in the database, okay. So for example, customer one has three records, okay, three loans. Sorry, customer one has three loans. Loan number one, two, three are associated to customer whose ID is one. Okay, now if I try to delete a loan whose ID is one, then what happens if I have cascade is equal to cascade type dot remove? Okay, because of that, it will try to delete even customer record whose ID is one from this particular table. Which table? Customer table. Okay, so now what happens? So then immediately database will throw a constraint violation exception, that is foreign key constraint violation exception. Why it will throw that exception? So this customer parent record whose ID is one is also having few more child entity records. If you see loan number two, loan number three is also associated to this customer record whose ID is one, right? So obviously database will not allow to delete a parent record whose ID is one. So that's why what I am trying to say here is, do not give cascade is equal to cascade type dot all or cascade type dot remove at the child entity side, right? Due to that, it will try to internally delete the even parent entity record also. So hence, by that way, database internally it will not allow to delete that parent entity record by because parent entity still has few more child entity records. So obviously, it will not give the permission to delete that parent entity record, right? Yeah. So this is one point. So that's why I have not given this one. So now let's come back to this test case. So now I'm trying to execute this particular one. So now obviously, since we don't have cascade is equal to cascade type dot remove, it will delete only the loan record. It will not try to delete its associated customer record. So we are good to go. So now once this test case is passed, okay, now if you see in the loan table, okay, so out of 5 records, first record gets deleted shortly. Yeah, test case is passed. I'm just refreshing. Yeah, as I said, if you see, first loan record got deleted. Okay, so now let's see the last test scenario. Okay, so here if you see, I want to delete all loan records of a specific customer. Okay, so for example, okay, here customer okay, I'm just passing customer whose ID is one. Okay, I want to delete all loan records of a customer whose ID is one. So that's why if you see delete by customer ID, okay, as I said, I mean, I have written one derived JPA method. Here you can see delete by customer ID. Okay, that is annotated with @ transactional. Okay, so now if you see here, okay, um, so once this line gets executed, obviously it will internally delete all the loan records of that particular customer. Okay, only loan records. Do remember that customer records will be intact. That will never get disturbed. Okay, so just to cross verify, I'm just fetching all the what you say loan repository dot find all. Okay, but I think I need to change this logic. So see why? Because so we do have what you say um, few, I mean, two more records, right? Whose customer ID is two. Here you can see total we have 4 records. So now shortly I'm going to delete first two records of customer ID 1. So obviously then the left out records will be 2. That is, loan records so whose ID is 4 and 5 will be left, right? So for that, I think obviously I need to change the size to 2. Okay. So now I'm just running this particular test case and note one more point here. Okay, so we need to annotate this particular method with at the rate transactional. Why? Because internally uh, it has some shared entity manager. So we need to hold this particular transaction by the shared entity manager until it deletes all its loan records of that specific customer. Okay, in case if something goes wrong, okay, obviously it needs to roll back all the uh, particular what do you say actions back. Yeah, you see test case is passed. Okay, here you can see obviously the first two records, that is that means loan ID whose loan records whose ID is 2 and 3 will get deleted. I'm just refreshing in front of you. Yeah, you can see we have only two records, that is 4 and 5 loan IDs which are associated to the customer ID of 2. Okay, so in case if you don't give this at the rate transactional, then internally it will throw an exception stating that no entity manager found or something like that. Okay, so yeah, so overall what we did, we just maintained at the rate many to one unidirectional association. Here you can see in the loan. Okay, so by that way we have performed few operations only from child entity to parent entity side. Okay, so we do not have any association in the parent entity side. Here you can see in the parent entity side nothing, we don't have anything. So whenever we have this kind of requirement to do few operations on the child entity side, okay, so then we can keep this at the rate many to one and we can achieve our requirement. Okay, so yeah, so here if you see what and all we learned the key points here. So here if you see we can keep cascade is equal to cascade dot persist, okay, as an attribute to at the rate many to one, so that whenever we save a loan record, so happily it will save its associated parent entity record also in the database. So that's the beauty of cascade is equal to cascade dot persist. Okay, now as a second point, do not keep cascade is equal to cascade dot all as an attribute to at the rate many to one. Okay, and what happens if you give cascade is equal to cascade dot remove? So then as an attribute to this one, then when we try to delete a loan record, okay, child entity whose ID is 2 for example, okay, then it will try to delete its associated customer record of that is nothing but a parent entity 2. Okay, so then however that parent entity has few more child records in the database, okay, hence it will throw foreign key constraint violation exception. So that's what I have explained sometime before. Okay, and the last key point here is when we try to delete the loan records by customer ID, then we need to annotate this derived JPA method with at the rate transactional in the loan repository. So like below. Okay, why? Because so that it can make sure that all loan records are deleted. Otherwise, everything needs to get rolled back. Here we need to annotate with like this. Okay, yeah. So these are the key concepts of this at the rate many to one. Okay, yeah, if you like this video, please like and share and subscribe to my channel. Thank you.